Hello everyone, welcome to Toppscholars, the smart learning app. Today in this lecture, we are going to discuss some of the previously asked questions from the last 5 years for the Maharashtra State Board 10th standard examination. And today the chapter that we are going to discuss is heat. Okay, so let's begin and let's see these questions. Okay, so from the year 2019 till 2023, so these are the statistical data, as we can see, for different years, right? 2019, 20, 21, 22 and 23. We have had 1 mark, 2 mark and 3 marks questions from this chapter. Like here we can see in the year 2019 we have got 1 question for 1 mark and 1 question for 3 mark. In the year 2020 we have got 1 question each for 1 mark, 2 mark and 3 mark. Then we have got 2 questions for 1 mark in the year 2021 and again here 1 question for 3 marks. Then in the year 2022 we have got 1 question for 2 marks and 1 question for 3 marks. And then in the year 2023 1 question for 1 marks and 1 question for 3 marks. So in total, if you look at here, then we can see 4 marks plus 4 marks, 8 marks and 15 marks. That means in total we have got 23 marks of questions, okay, that have been asked in the last 5 years from this same chapter, okay, in the Maharashtra State Board examinations for 10th standard. Okay, now after looking at this data, we can see that this chapter is also very important from your exam point of view, because this chapter is not only important but it is very easy also. The concepts that we get to learn here are also quite easy to understand. So that's why this chapter is a scoring chapter. So that's why we have to focus on this chapter also. Now let's look at the actual questions. So here is the first question. Okay, so it's a simple question, but before we start with the question, just want to tell you that we are going to have a look at all the questions, but at the end of this lecture we are going to see the solutions or the detailed solutions of some of the important questions. Okay, initially we will see the questions and just have a look at the solutions in a short, but at the end we will see the detailed solution for some of the questions. So here is the first question from the year 2019. So we can see question is, water expands on reducing its temperature below what temperature, right? Dash degree Celsius. So it's a very short answer, 1 mark question. So as we know, the answer is 4 degrees Celsius, right? Water expands on reducing its temperature below 4 degrees Celsius, right? So this is also called as anomalous expansion of water. Moving on, here it is. This is from the year 2019. So explain the following temperature versus time graph. Okay, so here a temperature versus time graph has been given. Okay, so we can see here on y-axis we have got temperature in degrees Celsius and here we have got time. So you can see here the numbers are given 0, 10, 20, 30, 40, 50 up to 100 degrees Celsius. And here we have got time 2 minutes, 4, 6 and up to, let's say, 34 minutes. So this is a random data that is given, but this temperature is very important. So we can see here, as the water or let's say the liquid is given some heat, then definitely its temperature increases. So here we can see initially when the temperature was below 0 degree, right? We can see that when the temperature is below 0 degree, then the graph is over here. So we are in the negative temperatures, let's say minus 10, minus 20. So here we can see that when the heat is given to it, then its temperature is increasing. Okay, now when we reach here at 0 degrees Celsius, as we know that in this case, initially when the water is below 0 degree, it is in solid state, right? It's ice, right? It is called as ice. But as we reach here at 0 degrees Celsius, when the water reaches 0 degrees Celsius, initially it is at solid state, but as we add some more heat, initially its temperature does not change. Okay, only its state changes. That means it just converts from solid state to liquid state, but the temperature remains same, that is 0 degrees Celsius. So that means the liquid water, it can exist in both states, that is solid and liquid, at 0 degrees Celsius. The only difference is there is a difference in heat content inside the liquid. Okay, so here when the liquid is here, okay, at this state, then it is in solid state, but in this range you can see the temperature is 0 degree itself, but it goes into liquid state. So the difference is heat content. Here in this range the heat content is more, but here the heat content is less, and basically this hidden heat, this is called as latent heat. This is called as latent heat. Okay, now moving on, as the temperature now increases, as more heat is added, now the temperature goes on increasing. Now in this case the water is in liquid state. Okay, now in this case the temperature will go on increasing uniformly, and after reaching here, let's say, now you can see the temperature is exactly 100 degrees Celsius. So that means what? That means it has reached its boiling point. Now here, just at this state, the water is in liquid state, but after crossing this, or if you add even more heat to it, now it will convert into vapor state. But again the thing is, even when it just converts into vapor state, then the temperature initially remains 100 degrees Celsius itself. The water, when it is at liquid state, the temperature is 100 degrees Celsius, but when it just converts into gaseous state, that is a vapor state, then still its temperature is same, but only thing is there is a difference in heat content in this range, and again it is called as latent heat. Okay, so this is the explanation of this particular graph. Okay, moving on to the next question now, from the year 2020. So here the question is, the vapor contained in air is measured using a physical quantity called as absolute humidity, right? So the vapor contained in air is measured using a physical quantity called as absolute humidity. Next is, how much heat energy is necessary to raise the temperature of 5 kg of water from 20 degrees Celsius to 100 degrees Celsius. So there is a simple formula for that, which involves the specific heat capacity. So the amount of heat required, that is delta Q, is equal to the specific heat capacity C, or in some books it is written as S also, C. Then we have got the mass, and then we have got the change in temperature. So basically the specific heat capacity for water is, as we know, 4.2, right? It is 4.2. Just put it over here, and then mass is given, and then the change in temperature is also given, right? 20 to 100, that means 80 degrees Celsius, that is the change in temperature. So just put these numbers and you will get your answer. So it is a short answer question for 2 marks. Okay, moving on to the next question now. Here it is. Observe the given graph and answer the following question. Okay, so here we have been given a graph. Here on the y-axis we have got the volume and volume of water, and here on the x-axis we have got temperature. So the first question here is, name the process represented in the figure, and the second question is, at what temperature does this process take place? So it's very simple, right? We can see the graph is somewhat like this. That means here what is happening is, as the temperature is increasing from 0 degrees Celsius to let's say 10 degrees Celsius. So we can see that initially the volume is decreasing. Then again we can see the volume is increasing, isn't it? At 4 degrees Celsius, we can see here that the volume of water is minimum. Now, volume, okay, if you talk about volume, there is another term called as density, and which is nothing but mass per unit volume. So, if the volume is small, density is large. That means at 4 degrees Celsius, the density becomes large. Okay, but if you go in this direction, okay, if you reduce the temperature, then what will happen? Then volume increases. That means density again decreases. That means the water now starts expanding. If you look at this range here, now if you decrease the temperature, you can see that the volume is decreasing. So since the volume is decreasing, density is increasing. So since here the volume is decreasing, the density is increasing. So here the density becomes maximum, and again after crossing this value, the volume increases, so density decreases. That means the water expands. Here the water initially was contracting. Now again after crossing 4 degrees Celsius, it starts expanding. The question is, name the process represented in the figure. So this process is basically called as anomalous expansion of water, right? And then at what temperature does this process take place? So here we can see it takes place at 4 degree Celsius. Okay, moving on to the next question. The phenomenon in which ice converts to liquid due to applied pressure and then reconverts to ice once the pressure is removed is called as, so this is called as regelation, right? So moving on to the next question. So here we have got a very short answer question for 1 mark from the year 2021. Okay, so it's very simple, anomalous expansion or behavior of water. So here are the options. So temperature ranges are given. So as we know, basically this happens at 0 to 4 degrees Celsius, right? So therefore this is the correct answer. Moving on to the next question now. Here it is from the year 2021. Okay, answer the following question with the help of the following diagram. So here a diagram is given. Okay, here we have a hot object in contact with a cold object. Here there are some gas particles, and this we can see whole arrangement is enclosed, right? It is, we can say it is isolated from the surroundings. That means heat cannot get in or get out. So here the question is, heat is transferred from where to where? Which principle do we learn about from this process? And which property of the substance is measured using this principle? Okay, so these are the simple questions. So what we are going to do is, we are going to have a look at the solution later on in details. Okay, so let's not discuss it right now. Okay, moving on to the next question from the year 2022. Okay, draw a neat labeled diagram of Hooke's experiment or Hooke's apparatus. Okay, this is for 2 marks. So again we are going to discuss this question also at the end, so let's not discuss it right now. Okay, moving on to the next question. Here it is. Read the following paragraph and answer the questions based on it. So here, if heat is exchanged between a hot and cold object, the temperature of the cold object goes on increasing due to the gain of energy, and temperature of the hot object, okay, goes on decreasing due to the loss of energy. The change in temperature continues till the temperatures of both the objects attain the same value. So in this process, the cold object gains heat energy and the hot object loses heat energy, right? If the system of both the objects is isolated from the environment by keeping it inside a heat resistant box, then no energy can flow from inside the box or come into the box. Okay, so it's a paragraph that is given. Okay, now using this paragraph we have to answer some of the questions that are given. So one is this one: heat is transferred from where to where? Then which principle do we learn about from this process? And next is, how will you state the principle briefly? So if you look at these three questions, these are the same questions that were asked in the previous year also, in the year 2021, right? And we are going to discuss these questions later on also. Okay, and basically we can answer these questions also. Is it heat is transferred from where to where? So basically we know that heat is always transferred from hot object to cold object, or we can say it is transferred from object at higher temperature to a object at lower temperature. Next, which principle do we learn about, okay, from this process? So we can say here that the principle is transfer of heat from hot object to cold object. That is one. Secondly, we can say here from all this observation that for isolated system, okay, if the system is isolated, completely isolated, then the heat energy lost by the hot object must always be equal to the heat energy gained by the cold object. Is it? So that is the principle that we learn from this process. Okay, and this is how we can state the principle briefly. Okay, moving on to the next question now. How do you feel? Okay, now this question is from 2023. It's a short answer question for 2 marks. So how do you feel about air in the each of the following conditions? So here relative humidity is more than 60% and relative humidity is less than 60%. So here in this case, when it is more than 60%, we say that the air is humid, right? But when it is less than 60%, then it is, we call it as dry air. Okay, so these are the answer for these questions. Moving on to the next question from the year 2023. Okay, here it is. So here a diagram is given, okay, where we can see there is a wax layer, but here is a hot iron ball. Let's say this is hot copper ball and this is hot lead ball. Okay, so we can see they are kept over a wax layer, and due to their temperatures or due to their hotness, due to the heat energy inside them, they were able to melt this wax layer. Okay, and that's why they have just gone inside this wax layer. Here are some questions. Which element has maximum specific heat capacity? We have to justify also. Then which element has minimum specific heat capacity? And we have to justify also. And then define specific heat of object. So this is for 3 marks. Okay. So again, we are going to discuss this question also at the end. So let us not discuss it right now. Moving on to the, here it is. From now on, we are going to discuss some of the questions that we have already seen previously, but in details. So here is the question that we have previously read. Okay, so this is the diagram that we have already seen. This is a insulated box. This is air particles. This is hot object, cold object. They are in contact. So definitely heat will be transferred from hot object to a cold object. Is it? Then the question is also asked, heat is transferred from where to where? Then which principle do we learn about from this process, and which property of the substance is measured using this principle? Okay, so let's answer these questions. So here it is. Heat is transferred from a hot body to a cold body, that is a higher temperature to lower temperature, and this is from our common experience also, right? We experience this daily, right? Like for example, if we put our finger in boiling water, then what happens? We feel it very hot, right? Why this happens? Because heat is transferred from that hot water into our body. Moving on to the next. So the principle that we learn is heat exchange, right? Principle of heat exchange from this process. And then the last answer is the heat energy lost by a hot object is always equal to the heat energy gained by a cold object, provided that the system of both the objects is isolated. System is isolated, okay? Now, from this property or from this principle, we can actually measure one quantity called as specific heat. Specific heat capacity of a object can be calculated or can be determined using this principle, and that is what people do, right? So this is the answer. Moving on to the next question now. Draw a neat labeled diagram of Hope's apparatus. So here it is. This is the Hope's apparatus. Okay, you have to draw this diagram. Okay, so we can see here there is a freezing mixture over here. Then here you can see there is a small beaker kept to collect water, and then we can see over here there is a thermometer T1, there is a thermometer T2. Above this we can see there is a 0 degree Celsius. Here it is 4 degree Celsius, because what happens is as the water gets cold inside it, okay, as that water reaches 4 degree Celsius, then it starts to, okay, expand. And so as we can see here that the temperature here is 4 degree Celsius and here it is 0 degree Celsius. So basically we know that as the temperature of the water will be reducing, okay, initially the water will start to contract, okay. That means when it, let's say, it reduces its temperature from, let's say, 10 degree Celsius to 4 degree Celsius, till that it will contract, okay, contract up to 4 degree Celsius, okay. Then the density of liquid will become maximum at 4 degree Celsius. But if the temperature reduces below it, then the density of water will again decrease and it will come up, because the object which has less density, it always floats. So when the temperature becomes less than 4 degrees Celsius, it always floats. That's why here the temperature has to be 0 degrees Celsius. So this is basically the Hope's apparatus, okay, and this is the diagram that you will have to draw if this question is asked. Moving on, observe the following figure and answer the question. So this is the diagram that we have already discussed about wax layer. There is a wax layer, there is a iron ball here, there is a copper ball here, and there is a lead ball here. So we can see that iron has traveled a longer distance. This is a little bit shorter and this is even shorter. Okay, which element has maximum specific heat capacity? And you have to justify this also. Then which element has minimum specific heat capacity? And we have to justify that. And then define specific heat of object. And this question was asked in 2023 for 3 marks. So let's look at the solution for this question. Okay, so first of all, maximum specific heat capacity is found in iron. So we had seen that iron was able to travel a longer distance inside that wax. So basically what happens over here is that the hot iron ball, okay, when it is hot, it is having a higher temperature. To reach that higher temperature, it has to gain some energy. That means it has to absorb some energy from somewhere else, right? Then only it can get hot. So since its specific heat capacity is large, that's why it is able to absorb more heat energy for gaining some temperature or for increasing its temperature. That means for certain amount of increase in temperature, it requires large heat energy because its specific heat capacity is large. Because there is a simple formula for specific heat capacity, that is amount of heat energy required, delta Q, divided by change in temperature, or we can say amount of heat energy required per unit change in temperature per unit mass. Okay, So here let us assume that the masses of all these are same, okay, and here the amount of heat energy required per unit change in temperature, that will determine which element has got the larger specific heat capacity. So here, since iron has absorbed a large amount of energy for gaining a particular value of temperature, that's why when it came in contact with that wax, it was able to transfer large amount of energy to the wax, okay, as compared to other spheres that are given in the diagram, okay. And that's why when that large amount of energy was given to wax, then the wax was melt more, and that's why the iron ball was able to travel a longer distance, okay. So the lead sphere absorbs less heat, okay, which results in less heat transmission in the wax. So the sphere reaches the least depth into the wax in the activity. So here there is another ball we can see, that is a lead ball, and lead ball is not able to reach a larger depth, whereas iron reaches larger depth, right? The iron sphere absorbs more heat, which results in more heat transmission in the wax. So sphere goes the deepest into the wax. That's why we can see that maximum specific heat capacity is found with iron. Next, the minimum or the minimal specific heat capacity exists for lead. Just now we have discussed, because it is not able to transfer more heat, okay. Then the next is the amount of heat energy required to raise the temperature of a unit mass of object by 1 degree Celsius is called the specific heat of the object, okay. So this is the definition for specific heat, okay. So these are some of the questions that we have discussed today, okay, from the last 5 years of Maharashtra State Board examination, okay, from the chapter heat. So I hope all the questions that we have seen today are very much clear and very well understood. Thank you so much for watching, and all the best for your upcoming examination. Thank you so much.